A very good morning to one and all present here. And thank you for joining us at the 3 days international conference on computational techniques and intelligent machines in collaboration with IEEE Computer Society, Waterloo Section, Canada, MSEST, Morocco, SIRG, Egypt. It gives me an immense pleasure to welcome all the participants today for the 3 days international conference ICC TIM 2020. I welcome all the eminent speaker and guests from all over the world to share their knowledge and vast experience with the community. In this session, the theme of this session is advances in ambient intelligence and its applications. And in this session, chairperson is Professor Jamnam Jayanta. Co-chairperson is Professor Navdeep Kochar. For the plenary talk, we have Professor Dr. Lalit Garg. And for the invited talk, we have Professor Jamnam Jayanta. In this session, 7 papers will be presented. And for the plenary talk, I would like to introduce Professor Dr. Lalit Garg before inviting him for the plenary talk. Dr. Lalit Garg is working as a professor in Department of Computer Information System in University of Malta. He received his PhD in Computing and Information Engineering from University of Ulster, UK. He has more than 19 years of teaching and research experience. His research area is modeling and simulation, information system, operational research, biomedical computing, knowledge discovery and data mining, blockchain, and its applications in healthcare. Dr. Garg has supervised more than 200 Masters of Science students. Many of these were sponsored by industrial organizations. He has also co-supervising 2 PhD students at University of Malta. Dr. Garg has published about 40 research papers in refereed journals, 2 edited books, 13 in refereed books, book chapters, 54 papers in refereed international conferences. He has received many best paper awards in national and international conferences. Dr. Garg has nominated in the Operational Research Society Doctoral Prize, most distinguished body of research, leading in the award of doctorate in the field of operational research. So now I would like to invite Dr. Lalit Garg for the plenary talk. So now I'm handing over the mic to Dr. Garg. Sir, please.
Thank you very much indeed, Mukesh, for such a nice introduction. And a very good morning, everyone, or good afternoon, or good evening, wherever you are, based on that. Well, I'm based in Malta, so it is early in the morning. It is 5:46 a.m. I hope you all are doing great. In this difficult, challenging time, you are keeping safe, healthy, and happy. I would like to have permission to share my talk. So let me share it now.
Yes, sir, it is visible.
Good. So to avoid any interruption, I just recorded it day before yesterday. Okay, so, and I also sent you. So let me start this, and feel free to ask any question whenever you have one. I hope you all are doing superbly well and enjoying the conference today. So my talk is Artificial Health Intelligence for COVID-19 Outbreak Management. Here I will discuss some of the projects we are working on related to artificial health intelligence and their applications in COVID-19 outbreak management. Okay. So COVID-19 is affecting almost everyone, more than 7 billion population. Every country is struggling to deal with that. Many countries are facing second wave, or some are even facing third wave. So and efficient management is necessary, and we are trying to see how artificial health intelligence can help to better fight against COVID-19. So the first application of artificial health intelligence in COVID-19 management is this dashboard developed by Johns Hopkins University called GeoAI. It is showing the situation of COVID-19 in different countries, including number of cases, number of deaths, cases per million population, and deaths per million population testings, and all this information greatly help countries to make their policies accordingly, learning which country is doing better, and learning policies from each and sharing their knowledge with each other. So there are many different views, and based on this, the data is being used by many other applications like webometrics to show it even more presentable. So why we need artificial health intelligence? So as we know, the COVID-19 outbreak is not just a medical problem, but it is also a social problem, political problem, cultural problem, community problem, communication problem, transportation problem, management problem, supply chain problem, administration problem, education problem, financial problem, economic problem, behavioral, a psychological problem, geological problem. So it is affecting all walk of our life. So we cannot solve just by using medicine. We have to develop some holistic approach to deal with such a problem, where we have to take care of all the factors. For instance, even if we have sufficient number of medical professionals, we do not do contact tracing and do any restrictions, and the infection is spreading quite fast. Even our best medical systems might collapse. We have already seen the best healthcare system was in Italy and France, and they have already collapsed or still struggling dealing with COVID-19 outbreak. So we need a holistic approach, and there are many factors interacting with each other, making this problem even worse. So this is a complex system. So we have to first understand what a complex system is with some examples. So this is a complex system where many entities are interacting to develop the end result, and it is not easy to understand the impact of one entity because their interaction is also having different impact than the individual effect. So one popular example is travel medicine. If you go somewhere, you keep some medicines, but you don't require these. Then when you come back, you realize these medicines are no more of use because these have expired. So is it a good news or bad news? Some might say it's a good news. Some might say you wasted money, so it's a bad news. Well, it's a bit complex. Similarly, another very famous story of Della and James. They were very poor and they wanted to gift each other. Della wanted to gift a wristband to James, and James wanted to gift a hair clip to Della, but they sold their possessions like wristband and hairs to buy gift for each other, and then they realized the gift is of no use. So it was a happy ending there, but in practice it is not, being a complex system. They were not aware what is going on the other end, but if they have a phenomena or some mechanism to understand what is going other end, they might have avoided this. So in practice, this might be, the end result might be this or this, if it is happening repeatedly. So to deal with such scenarios, we need human behavioral modeling the effect of others behavior using game, modeling of cultural, social, economical, financial, and environmental effects using big data analytics, and most difficult, modeling spontaneous changes in sentiments. So ultimately, we have to see the difference between the reality and the perception. Perception comes from our experience, which might be quite different from the reality. But we need to develop solutions based on the reality, not just based on Perception might help us to understand what should be done, but the solution should be based on the reality. So this is another example. We can see how countries are struggling dealing with this problem due to optimism bias. Many people are not following the regulations because they perceive that this will not affect them, this will affect only other people, so they are against of many restrictions. And yes, some restrictions are quite harmful for economy, or even some are facing psychological problems due to these restrictions, so they are opposing these. And some are just due to optimism wise, they are opposing these. Even some are opposing vaccines, you know. So there we need to also understand our healthcare system, how its dynamics, because it's again a very complex system. So there are two types of healthcare systems, public and private. Many countries have private healthcare system, while others like Malta, the UK, Canada have public healthcare systems, and many countries like India have both healthcare systems working together. So in a private healthcare system, our aim is to provide cheap healthcare or luxurious healthcare, depending on who is looking for what. So some are interested in cheap healthcare who are cost sensitive, while others are interested in the luxurious healthcare. So for instance, in many countries like Singapore, hospitals are even better than five-star hotels. Health providers want maximum profit, so for getting maximum profit, they try to make maximum hospital visits, either by attracting maximum number of patients or discharging patients early, so that they might need readmissions. And sometimes they are just keeping patients for a longer duration, although they are suitable for discharge. So there is a discharge delay, which is contributing to their profit. While you might think that they are doing very bad, yes, but they are also there for profit. If they are not generating profit, then they will not open hospitals. And if there are no hospital or no private hospital and no public hospital, then you can see you might not get healthcare services. So we have to see some other solution, not just by restricting them from having profit. We should have a regulation to minimize or to regulate their profit. While in public healthcare systems, everyone gets the same healthcare. Health providers want health providers want minimum cost. Minimum cost means limited resources, least duration in hospital, and minimum admissions, which will result in waiting list. And if there are early discharge, then patients might need more readmissions, which will also contribute to the waiting list. So there will be a longer waiting list. Many patients might die while waiting for their turn to get seen by the doctor. It might result in the poor health, public outcry, and preferences. Someone tried to kill the waiting time by using some other means, for example, finding some relatives as a medical professional, giving them a separate route to enter to the hospital, or by spending money or using their power. So everyone will not get the same health care. It will result in corruption. So to solve this problem, you might say we might need more resources. Yes, but because these healthcare systems are funded by the taxpayers' money, so there will be more taxes and more cost. It might result in waiting list and longer hospital stay. While longer hospital stay has a negative effect, is delayed discharge, where the patient might acquire hospital acquired infection. So that might be fatal as well. Like many patients are getting infection while they are being treated for some other disease. and COVID-19 patient is near vicinity and they are getting COVID-19 infection, which is becoming very fatal for them, and sometimes they might acquire some other infections. MRSA. Okay, so there might, but yes, the advantage is they might need minimum admissions and more patients will be there, because earlier waiting list is distracting patients if they do not need urgent medical attention or they are not severe. But if there are beds available, there will be patients who actually do not need medical attention, but because there are beds available, and even for a small disease or ailment they might see a doctor there. Sometimes there might be underutilization of resources and beds are empty, or misuse of resources as we have seen. So it will result in more cost and some waiting list, because patients flow is not uniform. Sometimes we have more patients and sometimes we do not have patients. Even there is a seasonality. So like for instance, after Christmas vacations there are more admissions to the hospital. Similarly, even the length of stay is affected by weather and air quality. That's what we found in our research. So even we are having almost infinite number of beds, still there will be a waiting list because of this seasonal nature of patient arrival. So to solve this problem, we need optimum resources, optimum waiting time, optimum hospital stay, minimum readmissions, optimum patients number, optimum utilization of resources, minimum misuse, and optimum cost. To ensure all these and some waiting list, we need resource requirement forecasting, so that we can exactly forecast how many beds we might need at a particular time. And if we do not need beds, we might find alternate applications of these beds. We might do admission rate estimation and length of stay admission to see the bed occupancy and requirements to better manage the resources. And if population is growing, we need to continuously add more resources to take care of the population. So, well, as I was showing in the beginning, there are many other dashboards. So the popular, my favorite dashboard is from Webometrics, which is showing how different countries are having number of infections or total number of infections, total number of deaths, deaths per million population, infection per million population, and tests million population. So you see here, based on total number of infections, India was second rank, while Malta, and based on total number of deaths, India is at third rank and Malta is at 125. But this is not a true picture, because the population in India is quite large and the population in Malta is very small. So it is not the right comparison. So the better comparison is total cases per million population. And here we can see Malta is at 47th rank while India is 102 rank. So India is doing better than Malta, but the case definition is different in both countries. Like in Malta, anyone who got positive results, they are considered as infected, while in India, those who are showing symptoms and then got positive result are considered as infected patients. So deaths per million population might be more reliable comparison. So here Malta is having 53 rank while India is having 95th rank. So still India is doing better, and number of deaths per million population in Malta is 251, while in India these are 96. We are saying that more tests means less death. So let's see that, and here this is the comparison of number of tests. So here we can see Faris Island is having maximum number of deaths, almost 3 times of the population. So, and number of deaths fortunately are zero, while at the same time Gibraltar, which is also having 2.5 times of the total population, these are the number of deaths, but still there are 89 deaths per million population, which is slightly better than India. In India, these are 96 deaths per million population, um, while another country, Andorra, is having almost double deaths than the population, but still number of deaths per million population is 983, or almost 0.1%. So we have to see many other factors affecting the death rate and even total number of infections, not just tests. These factors might be per capita income, economic growth, healthcare system, weather. There are many factors we can consider. So, considering these, we are working on some of the projects which can contribute to controlling or containing this COVID-19 infection. So, one of the project is anonymity preserving IoT based contact tracing model. In India or in many other countries, there have been contact tracing applications. Like in India, this was called Arogya Setu. However, the problem with such contact tracing applications is these might be threat to our privacy. In Europe, privacy is a major concern, so we need apps which can preserve our privacy. Another problem with these apps is they need a mobile phone to download these apps, and also these apps are draining our battery quite quickly because they are using Bluetooth. So we proposed a model based on Internet of Things, more precisely RFID, and for preserving anonymity, we are using blockchain. So this project is funded by Malta's Research, Innovation and Development Trust, as well as Saudi Arabia's Al Faisal University. Also in collaboration with Birla Institute of Technology, Ranchi, India, and ABV IIITM Gwalior. So this COVID-19 infection spread through contact. So one person might contact many people and spread the infection to these people. So it's a chain which is multiplying quickly depending on R factor. So to kill this chain, we need a contact tracing model so that we can alert users about a positive case nearby so they can make a better decision. So, however, the infection might spread not only by human to human, but also through animals or vehicles or any other moving object. So, this system can trace not only human movement but also animals, vehicles, or other movements. So, based on blockchain's trust-oriented decentralization for on-chip data logging and retrieval. It allowed moving objects to receive or send notifications when they are close to a flagged, probable, or confirmed diseased case, or flagged place or object. So we can find out hotspots, even we can make decisions where might be the best to buy the grocery, where might be more chances of infection, so we can avoid that. It was quite fast, so it can also help us in understanding the human connectivity better, in modeling similar other infection spread out network, in developing public policies to control the spread of COVID-19, finding super spreader hotspots, and responsible behavior. So we can develop various policies to control COVID-19 spread or even contain it. So this is a schematic model where we have RFID reader and RFID tag attached with each moving object, including human, machine, animals, and vehicles. Okay, and this is blockchain network where we will keep the identity. So it will not really reveal the identity. It will just mark up a patient as positive if he diagnosed positive. So using that model, we can also develop a disease network where we can understand how disease is spreading, how people are coming in contact with each other, and not only people, animal, and any moving object. So through that, we can design such network. We can monitor that networks or monitor the effect of policies. We can track how a policy is responding, and we can also track how infection is increasing or decreasing. We can share this information, analyze this information, and learn to better deal with the infection spread. We can predict and prepare our healthcare system to deal with this. Another application is to develop patient lifelog sharing. So we can develop patient lifelog where we can keep record of medical history, travel history, activities and behavior, and family history of each patient. It will help us to better forecast the healthcare resource requirements based on each individual patient's requirement, based on his or her medical history, travel history, activities and behavior, and family history, so that we can ensure sufficient healthcare resources are available for each patient. Because during COVID-19 outbreak, you might have seen news where hospitals were struggling to decide which patient they should treat and which patient they should not treat because of lack of resources. So this can help us. Even we can do some simulations using the patient life log to ensure at the time of such spreads or even natural disasters we have sufficient resources. So this is the paper published in IEEE Access, based describing this in more detail, so you can go through that. Another very interesting project we are working on is a masked image recognition system. When you travel during COVID-19 and you go to airport or other places, you might need to remove your mask in front of a camera, but being a single point for everyone to remove that mask because of the location of camera, it might spread infection because the virus can stay in air for few hours, and within that time if someone else is coming at the same place, he or she might get infected if he or she is removing his mask. We have seen that scenario in banks as well, where they need to keep track of identity of everyone coming to the bank. So we are removing mask at a particular place. So that might be dangerous. So we can have, we are trying to develop a mechanism where we can have a face marks image and reconstruct an image by removing that mask without asking the person to remove mask. So using machine learning, we can do that. However, there is a risk of revealing identity of those who are not interested to reveal their identity because of some reason, and so this might be a threat of their privacy. So instead of making just image processing model, we made a model where patient has right to reveal or not to reveal his or her identity. So we will use a database where we will keep all identity information or images of each user who is participating in the system, and then whenever they are in a vicinity of other person, they might get message from other person who is in the app, an alert who is asking for revealing the identity, and then the person might decide if he is interested to reveal his identity or not. So he can select that option and give permission. So it is using a hashed value of image and masked image combination linked to users for cryptographic image identification, a machine learning model trained with maskless and masked human image pairs for image recognition purpose. First, an online facial image database is used, and then several participants are also recruited. So this blockchain model is cost effective and using machine learning and AI recommender system and user interface. Another interesting project is again related to COVID-19 is healthcare self-service kiosk to minimize the contact with the healthcare professionals or doctors. And here we try to provide maximum services through this kiosk without or minimizing the contact with the doctor. So these services might be their history, patient history, their appointment, even they can take their blood pressure, temperature, weight, and based on that it can decide which might be the right or the best specialist to take care of the patient. So not reducing the waiting time for patient for this decision. And we used Raspberry Pi to develop the prototype. So this is a schematic representation. Another interesting project is hospital bed occupancy and requirements forecasting. As I have told you, the optimum requirement forecasting or the best requirement forecasting can help us to deal with such scenarios, better ensuring the resources availability. These are some of the papers we developed and published based on work, but there are many more. So it is in collaboration with Nanyang Technological University and Singapore and Tan Tock Seng Hospital, Singapore, and we were using Markov modeling, reinforcement learning, and data was provided by Tan Tock Seng Hospital, Singapore. This was also done at the Ulster University and Northern Ireland Health and Social Care Trust provided us data, and University of Malta is also part of this, and Mater Dei Hospital in Malta provided data for it. So we found out not only the patient arrival is seasonal, but also it depends on air quality and many other factors not directly related with the area where patient is. For example, sandstorm in Sahara might affect patient arrival in Europe. So we use satellite imagery for tracking these developments, and based on this we are predicting the resource requirements. So these are some of the papers based on this work. So if you are interested in knowing more, you can go through these. Another interesting project is missing data handling. The problem is sometimes data is available but there is lot of missing data or due to collection error or non-respondents or some other regions might respondent might leave survey earlier. So to deal with this, we developed models where we can still handle such data by imputing the missing data. So this is one of the papers. So it was funded by Nanyang Institute of Technology in Health and Medicine, Singapore, and University of Malta. So you can see an example is we are asking some questions to patients, and some patients are not comfortable or decided not to answer particular question, but even finding out relationship between different patient answers, we can impute these answers which are not actually answered by the patient. So, and this is not only in case of questionnaire, we can also find patient symptoms or other things, even the effect of medicine by this method. So this is using machine learning or collaborative filtering. So these are some of the papers. Another is medical decision support system for managing acute upper gestational bleeding. Here, what we are trying to do is to learn from the previous cases so that the machine can take decisions and have a knowledge base where all experience knowledge of medical professional is included and used for making decisions. So we took all the previous cases of few years, what information was available at that time and what decision was taken. Based on that information, machine will make models or patterns to relate with the case and the decision was taken. Then we will use it for medical students to train them, and if there is a discrepancy between the decision made by this decision support system and the decision suggested by the medical professional or the student, then the expert will see um, which decision is correct, and if the machine's decision is incorrect, then they will correct that decision and give this new decision in the database, so that using reinforcement learning in the next time, this will improve the machine. So this was again in collaboration with Nanyang Technological University, Singapore and Tantak Hospital. Another interesting project is HIV disease progression modeling, similar to COVID-19. This also infectious disease, contagious disease. So, and interestingly, some patients do not respond well to the treatment, and some patients respond very well to the treatment. So we try to find out the reasons, factors affecting their response to the treatment, and how their condition is improving or getting worse. Another thing is they need antiretroviral therapy at the right time. So we try to find out the best time to give them antiretroviral therapy. So this is one of the papers. So again, this is in collaboration with the University of Ulster in the UK and the University of Cagliari, Italy, and using phase type survival tree analysis, which we developed, Markov process model and Bayesian analysis, and Instituto Superior di Scienze Rome provided us. So these are some of the papers. So that is all. Thank you very much indeed for your attention, and I'm here to answer your questions. So please feel free to ask questions. Yes.
Thank you, sir. It's really a wonderful talk.
My pleasure.
If any delegate has any question, then they can please ask from Dr. Garg.
Hello.
Yes.
Yes, sir.
Good morning, sir.
Very good morning, Vikas.
Sir, we are very thankful for your presentation, sir. Number of projects you have conducted in the medical, those are very, very kind for the human being. And as far as my area is concerned, sir, I have one question, that which platform or the kind of software or the things that you have used to simulate, to implement these things. Kindly throw some light on that also.
Well, sure. Frankly speaking, these depends on the project requirements. Many factors will decide that, and our intention in research is not particularly focusing on a particular platform or software. So we try to have generalized solutions which can be implemented by using any software or tool. For research purpose, we mainly use MATLAB or R. It depends on the funding as well, because some fundings do not like us to use open source software. So we have to go for MATLAB, and some solutions we borrow from others. So then we are restricted to the tool or the platform they developed that solution. For example, if they have used C, C++, we do not want to redevelop that. So we use it, we integrate it with the other tools which we are using here.
Okay, sir. Thank you, sir. Thank you.
You're most welcome.
Okay, good morning, Dr. Garg. This is Jayanta Singh. I have also two small questions. You have used data handling or the missing data handling algorithm. So I want to know that how large is the database that you are using, or is there any specific algorithm or application that you are using for handling large database? Because in fact, myself also working in data mining, in data warehousing, sometimes we are facing a lot of problem to handle the large database? This is one question regarding handling the large databases for missing values. And another one is we are also interested in starting something in the blockchain. So what application that you are using so far so that this can help in your research?
Okay, very nice questions. Both are very interesting. So the first question is missing data handling. Well, we are using in two domains. One is medical questionnaires, where there are chronic diseases and patients' treatment decision is based on their responses, and there is no fixed treatment because these are mainly psychological diseases. So we try to impute the answers which they are not comfortable to answer, and in that case the data set was not too large. Okay, then we used that method for reconstructing images as well, where there is missing data. So, and in that case these were quite large. Now training the machine might take longer. So for training the machine offline, we can use a cluster of multiple cores. Okay, like we were using 241 core cluster here, 240 core cluster here. So it depends the problem, but yes, and interestingly, it all depends on the nature of data. Like for most of the images, even we can reconstruct image by if there is more than 50% missing data, while in questionnaire we are restricted, although we can reconstruct or impute, but according to medical guidelines, we should not use data more than 35% missing values. So the second question about blockchain, well, it again depends, but yes, we write small programs and we integrate them with like if we are using open architecture like Ethereum, then yes, according to Ethereum, we do that, and they also provide some tools where we can just cut and paste our programs. And if we are using private blockchain, then we have to follow their own guidelines, and DevOps are available, developers, so we can use these.
Okay, thank you, sir.
Okay, thank you, sir. Next, for the invited talk, we have Professor Dr. Jamnam Jayanta. So before inviting Professor Jayanta, I would like to introduce about Dr. Jayanta in brief. Dr. Jayanta is working as a director at National Institute of Electronics and Information Technology, Guwahati. He has also worked as a professor and head in Department of Computer Science Engineering, Assam Don Bosco University, Assam, India. He has also worked as a senior lecturer in many reputed universities all over the world. Professor Jayanta received his master's and PhD in computer science from Dr. Bhimrao Ambedkar, Marathwada University, Aurangabad, Maharashtra. His research area is data science, ETL, data warehousing and mining, cloud computing, blockchain technology, image processing, IoT, etc. He has published numerous peer-reviewed papers in national and international journals. He is also a member of many national and international committees like IEEE, ACM, IETE, IAENG, IACSIT, IJET, Eurosys, etc. Dr. Jayanta is currently working. Dr. Jayanta is working on many R&D projects related with the social causes. So now I would like to invite Professor Dr. Jayanta for his invited talk. And now over the mic to Dr. Jayanta.
Thank you. I think my screen is here now.
Sir, abhi, still it is not showing to me, but.
Okay, so it may take.
Yes, now it is visible, sir.
Okay, okay. So good morning to all the participants again, once again. I want to welcome all the participants for this today's talk in this national conference. I'm very much thankful to the organizer of Baba Farid College for inviting me for this wonderful talk. And also I'm very much thankful to our earlier plenary speaker, Professor Garg, and other my party where we are going to share co-convener and coordinator of these conferences. Just coming back to the some portion where Dr. Garg has initiated, I want to continue from there. There are a lot of problems are happening in entire Earth, even in the solar system also, because of the problems that the humans are creating. So my talk is related to the management of this e-waste management, and there are other ways are also there, but I will concentrate more on the e-waste. And before making this one, I also want to highlight that the paper that I'm going to present today is accepted as one of the book chapter for coming up, one of the book for Taylor and Francis. This is something about what is happening in the industry. My presentation will have two components. One is I can give the background of how this research come up, and another one is the real research. So the background is something like in this IT industry, or we say that the industry of related thing, there are a lot of servers are using. You can see the Amazon server. Amazon is using so many server. They are using a lot of rack spaces and so on, so on. The carbon emission or the energy consumption is very huge. For example, let's say that you have a computer, and that computer inside the CPU, the server storage, the computer conversion, networking, lighting, it is using a lot of energy consumption. At the same time, this is also helping in 2%, around 2% global carbon dioxide emission. So somewhere it is going to affect all our health. Now coming to the point, some of the researchers try at their best level to do something in the green computing so that this carbon emission and the usage of the energy can be minimized. And also you can see the 2-3 points that I'm highlighting here. By doing the green computing thing, we can reduce the usage of the hazardous material. What is this hazardous material is coming up in the next slide, and also minimize the energy efficiency of this thing by using some better algorithm, something like that. And the third one is a recycle thing, or you can say that it can be recycled so that wastes can be minimized. And the last picture you can see, whenever you purchase any freeze type of thing from 1992 onward, it was said that you purchase only those electrical item which is having this symbol energy. It is giving that by giving those institutions, those products which is having this energy symbol can consume less to less energy consumption, something like that. Because of this one, all those quality standards, everything's are marked. For example, for IT industry, the CMM level number 1, for the products that, Six Sigma, then for energy users, this energy Sigma, and other quality factors are embedded for services as well as the products. Now I go to the waste management. This is e-waste related to the electronic waste, whatever related to most of the what we guys are using as a researchers, as a student, as a professor. E-waste means a lot of electrical and electronics equipment, maybe part of that one or a full of that one. After consumption or during the consumption, we are generating a lot of things. You can see the list of the components that we use, maybe the laptop, the printer, air condition, the screen, monitor, and different mobile. I believe at least all of us change our mobile every 3 years or maybe maximum of 5 years. Even you don't want to change the mobile because of the strategies that mobile companies are making, from first generation to second to third, so on. Now people are aiming to use 5G mobile. What about the all mobile. So all mobile has to go to somewhere, and finally it will become the e-waste. Same thing is applicable to the computers, laptops, and other things. Now, these are some of the rules set by any type of government. Like there are something like, information has to be gathered. What are the things that you are going to check before bringing to any organization? Suppose you are bringing laptop to the organization, what should be the quality? So on, so on. There are a lot of categories, and there are a lot of check lines are given from the e-waste management group. Now I'm skipping this one. You can see the global scenario, something like 16 empty or 3.7 kg per inhabitant, means whenever there is a living being or a society is there, at least 3.7 kg of e-waste are gathering together. And you can see the global scenario, what is happening in China, what is in Japan, what is in India. Somewhere India is better, but it is increasing. And also some of these countries are becoming a global recycling hubs for generating e-waste, not for making profit, with a compulsion, because unless and until we don't do this e-waste recycling and other thing, the world is going to go in some other different style. So this is also another example that we found in collecting the data. You can see what is happening in India. Among all those top country, you can states, you can see down Maharashtra is leading, Tamil Nadu, so on, other states and cities. This is the data collected in 2014-15, and there are different rules are there. I am bringing all this scenario and the background, the rules and the regulation, because in my research we are using this one as a compulsory, key parameter, because I'm going to relate all these rules, the situation and the authority together, so that we can model something, so that the waste management can be handled in a proper way. And you can see what is said in e-waste rule 2016. It is saying that you can do the things, but the all those product which is going to relate to the waste, it should have some condition where it can be recycled. And another thing is, awareness program has to be provided by people who are consuming this one or who are producing this one. For example, I belongs to, let's say, IBM, where the chips are generated, or I belongs to Geo, where the mobiles are generated, or some other things are generated. It is my duty to create awareness, and it is also my duty to create proper collection disposal mechanism for the waste and the recycling thing also. The rule is saying something, and there are some rules are imposed to the people who are producing this one, and also the consumer, because there are a lot of people who ever seen a mobile also, who ever see a PC also, but willingly unwillingly they have to also a part of those waste, the mixing of all these environment pollutions, pollutant, and all these type of things, they have to be. Even the bone, small baby bone is also also infected to these waste management effects. So coming to next thing, there are two types of the waste management sector. One is informal sector. Informal sector, there are a lot of people are involved. Most of them are because of their job, because of their property, or because of their financial condition, they have to be involved in this type of thing. So it is considered that 95% of informal sector of waste management system are because of social economic condition. Then there is another rules and the regulation that provided for this informal, because there are formal and informal sector for waste management, but different rules are made for either for the formal as well as informal. So informal is very interesting, but the formal is very difficult to control, because from our organization, from NALIT, where I'm working, we tried our best level to give the awareness program, something like that. Some data are coming up later on. So some roles to be given in the informal is like collection of the waste material, dismantling the components, and so on, so on. Some rules are, I mean to say that for the formal sector as well as for this formal sector, there are rules are provided, and what they have to do, how they have to do, and from where they are going to get the funding, and all this type of thing. Now I go to one more, recyclable material, and this is a path. from the cycling to the sorting, dismantling to the recovery, and so on, so on. In the waste management rule, which is given in 2016 in India, all this information has been provided. And now you can also see there are different sections in the informal sector. This is divided like the collector groups, the segregator groups, and the recycler groups. Somebody wants to do research on this one, or somebody wants to start their startup in this one. There are a lot of money, there are a lot of business prospects are also there. Means you can become a stream 1, you can become a stream 2, a stream 3. Some of these things are discussing in later stage. And this is for the formal sector, the same thing. But there are schemes are available, different schemes are available for the formal sector as well as for the non-formal sector. Normally, the formal sectors are those people who has been registered properly under the IT Company Act of that country. Informal sectors are a mix. Some portion of those ones are registered, some portions are not registered properly. So this is some information that I am bringing. Percentage of the weight of the different material in the waste management. For example, you have a freezer, then you can see average weight of the freezer is something like 40, 48, something like that. The percentage of the content, the iron content is like 64%. Content, glass content, and other thing. Then you can see the washing machine, TV set, your mobile, and other thing. The percentage of different components, the plastic content, the glass content, all these things are given. Now this is another thing. For example, there is a PC. Inside your PC, what are the components that you have? You have the plastic component, the percentage, the lead component, the aluminum component, and all these type of the components. Visible components are easy to control, but the invisible components, and also where the non-formal sector has collected, somebody has to collect this one. If the formal sector people who are working the formal sector collected this one, this will be recycled properly. But informal sector collected this one, actually they use a lot of very dangerous processes to recycle the material. And this is also one recovery material to recycling. You can see that this is not only the waste material that we have. There are a lot of interesting like something like gold, silver, copper, and other interesting materials are also available in each of the electronic waste. Now I'm coming to another point. All the e-waste are not hazardous. Some are hazardous. So some scenarios are given in the this thing. For example, you can see the substances, something like arsenic. For example, this quality of arsenic, some small quality of arsenic is going to your water or air or some other food which is directly consumed by you. And we already know what is the effect of arsenic content food and other lead and other thing also. Something is okay, but when it is coming in the environment, it is coming to the environment where your child, the old ages people, and yourself is exposed to. There are a lot of problems are available, and so on the lithium, mercury, and other thing. I will cut short and here also. And this is the health hazardous impact because of the e-waste. There are different components are available over where all these the components available from the e-waste is affecting. Means your part of your bodies are vulnerable to most of the part of your body. Means the waste material, the contents in the waste material is vulnerable to any part of your body. Now coming to the point, you can just see the environmental effect. Left side is the cows who are eating the grass which is growing from those waste material, and what they take from them, what we take from them. We take the milk from them. You never know from where the cow eat the grass and how that grass converted into the milk and is coming to your house, and how you are consuming the milk. Yourself consuming fine, no problem. Above 18 is almost mature. But the small babies who is born is about to make it, or his brain is developing. Those small baby, nowadays many are adopting non-feeding of their this thing, and students, the small pupils are using a lot of milk products, something here and there. So you can just imagine from where the meals are coming. And right side is about the food process. Whenever there are something about the waste material, from the waste material, those plants, whatever is going to come as a food to your house, your kitchen, it is also processed under this, and all these things are consumed, and it is going to your stomach, from your stomach to different part of your body. Definitely, this is not only giving the environmental impact, it is also giving the human impact directly. Now, this is some of the hazardous operation that people are doing. There are direct exposed, there are indirect exposed, and the high risk exposure. You can see, in order to get some part of the copper, or in order to get some part of the gold which is available, it is considered that any of the mobile gadget that you are using, 10% of their component is made up of gold. Because of that, it is having a very good transfer of the information, conduction, and all this type of thing. That is why there are very good portion of content of copper and the gold. So people are using the burning, direct burning, in order to extract the interesting thing. Also, people use the acid bath. They don't consider about their health, and then with the using of the acid bath, they try to find out. And also, you can see the last picture. This is about the children, where these problems, the children are exposed to this one. Instead of going to the school, colleges, other thing, they are helping their parents to do the dismantling thing, and they are directly interacting with the process. So one thing is they are skipping their daily activity, like going to the school, tuition, and other thing. Another thing is they are directly exposed to the waste material where the toxic things are available. Now I go to another part which is very much concerned about today's days. We are using a lot of PPE. You see, these are the old PPE. Earlier, we were having a lot of problem before coming of this type of COVID. But after COVID, before, the waste material and everything was generated from mostly from the industry. Now everybody is contributing. Everybody, you, me, everybody, whoever a living being is contributing in order to increase the waste material. For example, you are using different PPE component in a different part of your body. And also every day, things are changing. That is why this is also very much important that in workspace or in your home also, we use thing which can be reused and other thing. So I will skip this one. And there are one more concept is coming up called as a ROHS, restriction of hazardous substances. There are hazardous substances available in every material, but using more than the capable limit, more than the permissible limit, that is a problem. So that the rule which is dealing regarding to this type of hazardous material, that is what we call as a restriction of hazardous substances. Whenever you purchase a new mobile nowadays, you can see your mobile writes about HROS compliant, maybe energy compliant. You can see you try to purchase 4th generation mobile or 5th generation mobile or the laptop or something like that. This symbol will be available. Okay, like that. The EU-US 2016 rules say what are the stakeholder we have to do, because somewhere we are also a stakeholder, because you are maybe you are a producer or you are a consumer or you are some other. Not only those consumer and the product provider, the people who are using, collecting, and also working on this waste material, those who are working in computer and electronics, definitely they are the stakeholder of this hazardous material as well as the EU. There are different rules are there in this rule. If those who are new to this one, it has 6 chapters. These chapters are given here, the general to all these things. If time permit, you can go to these waste material rules. And there are different schedules are provided here, what to be done, what not to be done. Suppose you are doing some research related to electronics, something like that. Someday you have to take the compliance. Means, for example, like we are taking the compliance. Let's say that all your equipments are working. For example, you are driving car. Every year you have to go for a test quality testing of the car, whether all the parts are okay, servicing, like that. Very soon the rule is coming to check this waste management compliant or not. I go to the next one. There are key aspects of minimizing. There are some legal actions are also there. You can see the red color thing. there is a penalty also. So far, everybody is not following. That's why we are okay. But once everybody started following, like we are doing for the registering the PAN account, or the that we have everybody is compulsory to have driving license, something like that, then the penalty will go e-waste compliant. If you don't go for the e-waste compliance, the penalty will go up to 1 lakh rupees, or maybe 5-year jail, something like that. The rules and the punishable offenses, it is also highlighting in this rule. And this is one of the some of the training that we have provided from NELIT. You can see, number one, we have provided this 1 day or 3-day awareness program to around 5,500 government employee all over India in 29 states and some of the union territory. And this is in the first phase of this type of projects that we are doing. And another one is the second project is just started, where we are planning to invite the entrepreneur to work together so that they can start something about this recycling plants and something like that. So now I'm coming to my work, that what we are planning. We model something so that these waste material type of things can be handled in a proper way. One is, in order to handle this type of things, we intend to use the remote sensing thing, SMS type of thing, and then proximity sensor and other thing. So one scenario of how our research is motivated is given over here. We want to provide e-waste collection as a service. As I say, there are startups who may be interested in doing the recycling thing, because the very important component, something like copper and then the chips, the gold is there. Directly you can convert this one into the money. So if you are keeping all these service together, then just like a cloud computing, you can also make something like a waste management collection as a service, and nearby all these environments. So let me explain some of these scenario how we put in our research. This is one of the information that we got during 2015. So number of the registered units you can see here. Total, this is the data of 2015. The total of the registered unit is less than 200, and then their capacity to handle is also very less. And also you can see the big states like Andhra Pradesh, big states like Gujarat, the number of the registered recycling body is less than 10. It is a very alarming thing. Now this is the old report of 2015. It has been improved, but there is not that much significant improvement in that one. So all this information that we got from all this collecting center, we collect by physical or by email or some information, then we try to develop a data warehouse system. You can see the portion data warehouse system. In this information, we collect, the government rules and the regulation. We collect the agencies or the private related other thing, all NGOs and the activity that they are doing. For example, there is a recycler. What are the activities that they are doing right now? And what are the rules and the regulations that they are complying, or what are the difficulties that they have? All these things are calculated, computed in the data warehouse. Then we do a lot of ETL, the extraction, transformation, loading, so that this can be bring into a warehouse system where different data can be grouped together. The rules, the difficulty, the success story, and other thing. Then we use the business related to the analytical system, data analytics system. Then we also emphasize what other things can be reduced, recycled, and reused. This is one of the design that we have developed for multi-purpose uses. Second one is, whenever all these informations are coming, informations are integrated together, there are a lot of transformation take place. Like Professor Garg has suggested about handling the missing data. There are a lot of handling the missing data. Nobody wants to give, whether the information is coming from the formal sector or the non-formal sector or the related government department. Nobody is willing to give the correct data, or whatever is saying is collect from the internet, collect from the availability. So data collection is a big problem, and also integration of the data is a big problem. For example, this type of research are doing at a national level or international level. There will be a lot of difference in the unit also. For example, we will say some unit and we will say some unit, but wherever in other part of world, there are different unit will be there, different practice will be there, different rules will be there. So integration and then all this type of ETL process is also a very difficult thing for managing this type of data. So I go to the next one. Another one is during this, once ETL process is happening, then we do a lot of data mart, means grouping of the data, similar type of data. For example, set of the rules. Then from the set of the rules, what are the rules which is provided? What are the rules which are approved? What are the rules which to be worked at the level? For example, from the district level to the state level to the national level, international level, like that. Then we also try to generate from this type of data mart, grouping of the data together. We also try to generate different reports that how many units already completed the auditing. The auditings are pending for which reason and other thing. This is just a simple data that I am provided, but this data can be generated from different sector, whatever all these attributes of the marks are given here. I go to another one. We use cube modeling or multi-dimensional data modeling, exactly similar to the normal data warehouse system, because by converting the data into the cube model, it is very easy to formulate, or it is very easy to model the data in 3-dimensional way. You can rotate all those activity here and there. So that's why modeling the data, the cube models are used. Now, in order to find out the correctness or the very frequent happening or very frequent penalties or very frequent success story, we use the frequent pattern tree. So frequent pattern tree is one algorithm which is available, very much common in data warehousing, and we use the header. Consider that these are the database that which is available from different side of all those recycler, all those state and other thing. Then we make the tree of this one, and slowly, and we can find out that which state is doing the best, which state is having deficit. For example, if I'm trying to find out the best story, then record number B, maybe this is from state number 1, state number 2, so they are doing the best. Whenever I'm trying to find out based on the city, that which are the city which is most clean, which is more dirty and something like that, by using the frequent pattern tree, you can construct all those your queries very easily. I mean to say that the large database are collected, and those database are collected and converted properly, missing value, everything, all data quality problem has been solved. Finally, we construct the tree. From the tree, the header of the tree, we can find out the best to best results. And this is one example that comparison between the cities. And also we are using the color base. For example, those cities we are having red color, they are in miserable condition. Those who are in the yellow, just like what is happening in the traffic signal system. Green is a better, because testing or the recycling thing or those rule has been implemented. Those cities who are having in the red, they are the cities who are having a lot of problems, lot more activity to start. So on. We also use optimal part collection for the start bin, and this is not that we have implemented in one specific city. This is implemented in our lab by giving some dummy dustbin we call as a smart bin, and some of these smart bins are used with implemented with proximity sensor. The proximity sensor will give us how much the fill percentage of the dustbins. So this is one model that we model, where the SMS system, the Wi-Fi systems are connected through with all these dustbins, and then route of the pickup car will be rotated as per the signal that we get from. For example, the bin number 3 is fill up 90%. Then it is a time for the bin number 3 to pick up. Wherever the bin number 2, even the route is making in that way, in the normal way, but from this sensor, from the proximity sensor, we will come to know that bin number 1 is yet to collect. And from here, we will also come to know that some bins are put in the wrong place. For example, a dustbin is not filled up in a week time, something like that. It is considered that it is not put in the proper way, proper place. And if the bin is filled up very fastly, very frequently, and then we consider that no more bins are available. From here also, not only tracking or finding the optimal path for collection of data, because it also generating a lot of fuel, and also is also helping to put more pollution system. What is happening in Delhi and the NCR region now because of the the smokes from different area. So by controlling this type of pickup trucks and other things also, it may be helpful. And also from those warehouse system, we can also find out the data considering like how much awareness has been given, the training, collection unit, dumping side, and other thing. Then from where the state can manage this type of information system, like the e-waste management processing will be in between. Then there will be community, there will be municipality services, there will be routing of the trucks, dumping site, then navigation through the smart phones and the smart bin recycling unit and all these things. And some authority who are sitting on the above of this one as an owner, the analytical analytics, can understand that in a state that much waste has been produced, these much rules are applicable, these much rules are followed by all those recycler, and then this much information about dumping site is required, from where the waste can be converted into many product form, and so on. The cities can be compared together from one state to the national level. So many information can be met that as a waste processing as a services for all. In the conclusion, I want to just bring that, by doing this type of researches, we can bring all the concerned stakeholders together, like the local municipality, all the central pollution control, everything, all the NGO together. One. Another one is for the better management of the waste material. Then another one is creating, user level skilling or the training by using a lot of new advanced tools, something like augmented reality, virtual reality together for the target options. And also we can start this type of training from the very small school classes. And also it can solve a lot of environment hazardous, and also it can help the policymaker as well as the entrepreneur who want to do this one. And at the same time, we can also generate a lot of database, so that some success story can be shared to the future generation. All together, collecting all these things, we plan that there can be a process called as a e-waste processing as a service, as a pet service. Tomorrow, day after tomorrow, this can be converted. Now in many cities, this has been given to the startups, and the many startups are controlling very nicely for picking up a dustbin item. Also, they are charging something very meager, something like 5 rupees, 10 rupees. This is possible. And also they are also connecting to many NGO who are working in this control of the e-waste management system. By using a lot of data analytics, artificial intelligence, and other thing, we can also help something to minimize the impact of such hazardous material. With this, I want to conclude my talk. Thank you. If there is any question, we can discuss.
Thank you, sir. Thank you very much. If anyone has any question, then they can ask from Dr. Jayanta.
Mukesh sir.
Yes, sir.
I don't have any question, but I want to thank Dr. Jayanta, Professor Jayanta, for touching an area which is rarely touched by the different speaker throughout the conferences I have ever had in the last 6 to 7 months. But I'm very thankful for the Professor Dr. Jayanta Singh for presenting so beautifully the things related to the e-waste, which is a very hot, I mean, this is a very an urgent issue that each and even NGOs, the government, the private sector players all should concentrate on this area. I'm very thankful to you, sir. Thank you.
Thank you, sir. Thank you.
Okay, then we are inviting presenters for the presentation. So first I am giving call to the Mr. Madhav Gupta for presenting his paper. And the title of his paper is a Predictive Analysis in E-Learning Systems. So I am handing over the mic now to Mr. Madhav Gupta for presentation. And I am requesting to all the presenter, so they please present their paper within maximum of 10 minutes.
Hello, am I audible, sir?
Yes, sir, you are audible.
Okay. Good morning, everyone. Myself, Madhav Gupta. So, thank you for giving me an opportunity to present my paper here. So, let me share my screen. Is it visible?
Yes, sir, it is visible.
Okay. So, so our paper title was Predictive Analysis for E-Learning System. So we have why we have chosen this topic because of the basically social importance of this project. So this was a basically a group project done by us, and there were basically other colleagues with me, and so on behalf of them, I am presenting this paper to you. So predictive analysis was like I guess so so there is an unavailability of platform which helps students to prepare for the IIT JEE exams, and there are coaching institute which basically offers a hefty amount to basically pay to prepare for their examination. Like coaching institute are considered to be the topper manufacturer of the top rank holders in the engineering entrance examinations. So they had to pay a hefty amount for cracking these entrance examinations. So the reason that most people who prepared for top institute are selected to score good marks in these JEE examinations are that like they got a better opportunity to study those topics which are like quite important for the upcoming examination. So we have basically incorporated that thing in our application, and uh, we tried our best to basically sort out those topics which would be important for upcoming examination. So these are some scenarios that we have around like 50 if they are like each year 16 lakh students appear for the IIT examination, and around 15.5 lakh students scores even less than 50%. So only the top 5% candidates are there to basically to get a good score in those entrance examinations. So and it has been observed that most of them are from the private coaching institutes. So there is a very neck to neck competition for going through them. So henceforth we thought of developing an application which will help people from or students from unprivileged background. Those are not available to, those are not able to pay that amount to the coaching institutes and prepare. So I should go ahead, and what we did was we use Python, and then uh, we use NLTK for basically processing our basically questions and from the previous years. So basically one thing that I want to point out here is we don't have any data set available for this project. So we made our custom data set from last 20 years JEE questions. We basically collected the questions from different coaching institutes and different portals, and then process them to basically for our application. So How we did this was, we have a question data set, and we stored all the questions and the topics tagged with those questions in a CSV format, and then we applied the our basically text processing. Like we first did the tokenization, like took the question and divided into tokens, and then we applied the stop words removal. Basically the words that are not basically useful for classification, we have removed those stop words, and then we applied the capitalization, uh, and then we basically applied the stemming was like removing the similar words, like if they are forces and force, so they should be considered only one word. Otherwise this will just create a noise in our data set. And then there was a limitization. So what in lemmatization, we basically replace the word with the common meaning. Like if there are two words with the same meaning, then we replace the second one. So these features was there that we applied for our text processing, like for processing every question. So after basically applying these text processing steps, we came to like feature extracting. Like we converted each questions to its the numeric form, so that it can be used for further classifications of the topics. So for classification of topics, we use three algorithms. So naive-Bayes, support vector machines, and the logistic regression. So what we did, we basically converted all the questions to the numeric features, and then we applied our these machine learning algorithms to our data set. So the most accurate algorithm came out to be the naive-Bayes, because as we know that the naive-Bayes algorithm works really well in NLP tasks. So I will talk about their accuracy later. And like in naive-Bayes, we assume that the features are not interrelated to each other, and based on that, it will predict the outcome. That what outcome it will basically what topic will be important for the upcoming examination. So and then we applied so here are some information regarding naive-Bayes. Basically it works on the Bayes theorem, like probability of hypothesis and probability of evidence. Like if we have probability of evidence given, then how we will calculate the probability of hypothesis. So these are some mathematical explanations that we used in our application. So next, we basically applied the support vector machine to our data set and to classify the important topics. So SVM, like we know, we that it works on a hyperplane basis, and it tries to find the optimal hyperplane. So we basically we have our question data set, and we applied SVM over it to find the, basically we have classes of topics. So once we applied the SVM, so it basically separate all the classes into the important ones. Next, we applied the logistic regression. So again, it was working on the same. It was working on the way, like if we have a question data set, then there were a number of features, and suppose if we have n questions, so for each questions we put it as a matrix, and then basically went on basically go through the algorithm, that how it will calculate the probability of an important topic. So with the naive-Bayes, we got an accuracy of about 70%. With SVM, we got an accuracy of about 65%, and with logistic regression, we got an accuracy of about 63%. So we also calculated the topic prediction to be 92%. So use cases of this was, as have I already told, like we have basically maintained our own custom data set, as it was not available anywhere. So we applied the different algorithms on that data set, We also use some graph visualization technique, okay, to depict the previous history of topics, which will be important for the upcoming ones, and which appears twice or which appears like thrice in the previous years. So impact on real world, as we know, the application is quite useful for students who are from under not so much privileged background, and those are like from weak financial background. And there is a future scopes, like in the JE papers, there is a section of maths also, but in JE papers the mathematic portion consists of some complex equation and complex symbols. So our future effort will be to basically process those mathematical equations and complex symbols also, and add the mathematic sections to our application also. Currently, we worked on physics and chemistry parts of the JE papers, but in future we will try to work on mathematic parts also, because that will require basically different field, mathematical language processing. So after going through them, we will try to incorporate the maths parts also in our application. So this was the timeline. As we have done all the steps, review and the prototype, and we tested also. So thank you. Anyone have any question? So anyone have any questions?
If anyone have any question, then you can ask from Mr. Madhav Gupta. Okay, thank you, sir. Thank you for your presentation.
Thanks, sir.
For the next presentation, we are inviting Chirala Rohit for their presentation, and the title of research paper is A Survey on Existing Malware Attacks, Types, Causes, Anti-Malware Program, and Malware Analysis Methods. So now I am calling Chirala Rohit for their presentation.
So there is no. So host is disabled the attendance screen.
Sir, we are designating you as a host. Just wait for 1 minute. Yeah.
Okay.
Now, sir, you have been designated as a host, and now you can share your screen. Yes, sir. Your screen is visible now.
Good morning, everyone. Today my topic about is a survey on existing malware attacks, types, causing anti-malware programs, and malware analysis method. So everybody is aware of the what is malware and viruses. So when it comes introduction, malware is an malicious software. Actually, malware is coming from the malicious plus software word. It is specialized malware to penetrate and destroy our computers and mobile devices, any electronic devices without the user knowledge. So, and malicious code, a malicious program that can implement in the software or a web application. For example, if the hacker wants to get your data or the session, they will easily, without the software, they just inject some malicious program into your session so they can handle the session. So Basically, malicious code is a kind of harmful code. We can say that web script designing, uh, which can lead to the backdoor security breaches and information and theft, data theft, and other potential damages to files and computing systems, as I discussed. It is a type of threat that may not blocked by the antivirus software on its own. But not all antivirus protection can treat certain infection caused by the malicious code, because malicious code, it can be changed time to time. So, which is different from malware. In malware, there is software, but in this code, everyone hackers can easily inject their malicious code into particular web script. So we did a survey regarding the cyber attacks. So the major cyber attacks are done by the malware only. It's considered in 2019, 35.61 malware attacks have happened based on all the cyber attacks, which is the major point. And 2.52 malicious script injection, as I told before, is a malicious code. Uh, for example, if we actually we will download the torrent files and some unethical software from the internet without paying the license. So every downloading software, 90% chances there is a malware in hidden with that software. Every day, billions of millions of attack accounts are compromising, and Windows systems are electronic devices are attacking to this malware attacks. So we did a survey on what's the cost of the single malware attack for the company. So it comes to the more than 3 million. Malware attack cost nearly 3 million for the company. So how can we predict that how my system is having a malware or any viruses? So the actually designed a simple block diagram for it. Malware functions and malware actions. When it comes to malware actions, we can see some unpredictable changes, newly executing files. For example, we will get a virus attack. What will happen? Our mobile device will get slow, and some malicious activity is happening. At some time, some other applications are opening. These are all the functions of the malware. So unknown new executable files are found in the our system, and some alter from altering the system, the home page, and extra content in the in our device. These all things happen. So I classified every malware. So for example, virus is a program which automatically spreading. Actually, every device, I think everyone got some virus on their phone, or virus on their phone, or ransomware attacks. Everyone actually heard about the news. So virus is the first category of the malware to appear on the computer security. It is a self-replicating in a nature, and it does not have a separate existing. Instead, it inserts the code into the existing files on the system. So when it comes to the worm, worm is just like a virus, but it can be replicated without the user consent. So, however, there are standalone malware strains. They do not modify other files to spread. Instead, they make copies of themselves over the network shares, like P2P and IRC, etc. When it comes to Trojan horse is an most causing malware problem. Trojan is always discussed useful software and tempts a user to install it, and it is also bundled with the hidden malicious functionality. It is not replicating in nature, but it does not spread in similar manner as virus or worms. For example, if you using a some advertising block will become download this antivirus. your system having some virus, download this antivirus so that your system will be secure. So that type of, it will directly manipulate the human brain to install it. That is called Trojan horse. And uh, what what can be used for good things or bad things? Generally, a bot is an algorithm automatically sends some request, or it helps the users. Is an algorithm. So it automatically defines the denying service, and a bot can when the bot enters the system, it automatically execute the commands from the command prompt, because it automatically changes the working of the system. And sometimes bots can be called as backdoor. So like backdoor means backdoor allows unauthorized access to the compromised system by opening a port on the particular system. This creates a path. Bot creates the path uh, for the hackers to control the compromised system by sending some commands, and which can be uh, executed by from the command prompt. So when it comes to the scary way, and it can be called as some rogue application, which actually is a fake application. Processors have security applications or system tools to mislead users into the paying for removal of non-existing malware, or uh, it can be used for P2P applications and video clips and video to run this particular scareware. As well as said in the Trojan horse, we will get some breezer, some vibrations on the phone when we are surfing the internet. Your system has this particular virus, install it. If not, your system will be hanged. That type of it only scare the user and deceiving the user. And in case of adware, it only annoys the people. For example, our Google system also is an one type of adware. When you search particular thing on internet or Amazon, it will, when you go to the other page, so we can see the same advertisement in left or right of corners of the page, because Google collects your data and they will advertise you. And for example, in adware, we will use some free applications in our system. We can continuously getting ads in the below, so they will annoy the users. That's all. The spyware. Spyware is a software that gathers personal or confidential information from the user system without their knowledge, accessing your audio system or camera. This includes monitoring the system to collect information such as browsing history, recently visited site password, credit card numbers, and confidential information. Once the spyware is uh, installed in your system, uh, it totally monitors the user activities, and it sends the information to the remote server, which is hacker is where the hacker is. And it's a ransomware. Ransomware is an type of crypto plus cryptological virus, which automatically encrypt our data and ask for some ransomware money to do. If you don't pay that ransom money, they will automatically delete your data like that. So these are the infection vectors. So malware attack can happen from anywhere, from the internet, from the hardware use, and from any sharing that some P2P connections. So for example, file infection, email worms. When you got an email, in that only some malicious script will be already added. When you download it, it automatically affects your system. So for example, take the removal video. For our friends also do this do this type of activities, and just they will insert some spyware in your pen drive, and when the pen drive is inserted, automatically it collects the data. For example, it is I'm saying that some real life example is taken place in the 2014, and Indian Navy agent got a pen drive from some unauthorized person. He just plugged it into his computer, which is in the Navy office. So the total data in the system is automatically sent to the remote user in the China. So it is so this type of attacks are majorly causing national security threat also. So actually, what happens when the malware enters into the system? And first it will cause the program encryption. Program encryption means it automatically encrypt our data with a particular algorithm which is already inbuilt in the software, in the malicious program. So most of today's computer worms and trojans are in very ways packaged or encrypted. Besides that, computer creates specially designed tool for packing and encrypting. For example, all files in the internet processed by the cryptXE and Xref and polycrypt. These are the examples of the program encryption. So when they enter into a system, they automatically encrypt your data and they just block your accessing the file. So some other malware just modify the program. For example, take the Trojan code. It has some particular instruction for that particular software. It automatically modify that one. As a result, Trojan functionality preserved, but the appearance changes significantly occasionally for the program molecule. If the anti-malware wants to detect you, the program automatically remodifying it, so it will be hard to detect for the malware. When it comes to undetectability, and Trojans are commonly so-called rootkit technologies, as I said before, and some anti-malware, sometimes registry branches with an Trojan copy register also hidden from the system areas of the computer. So it will be highly undetectable for the anti-malware to remove that one. So hide programs on the web page. In the first slide, I said about the malicious code. So when we're using the web process, some unethical person, hackers, or directly inject some malicious code into the web pages so that they can extract or collect your data, like credit card and your confidential information. So it takes time for the anti-malware also for detecting the new type of codes. And when it comes to the fifth point, numerical attack. In numerical attack means versions takes place. For example, if the if a crypto locker is current trending without we don't have particular signature for the crypto world, but within some time crypto world second version is released. So it is highly sometimes it can be complexity for detecting the anti-malware for this numerical attacks. So these are the normal methods anti-malware uses for detecting the malware. Signature based some anti-malware database already contains some signature bases. So it will just compare malware with the existing malware signatures in the database. It automatically matches, and this program signature files. If the signature files is not having in the database, automatically sends some request for the database. In case of hash values are like most like signatures only, but it reviews the value of the entire file. If the particular file is entered, it not only it will just catches the hash values. What is the hash values for MD5 hash values or some AES hash values. So it will automatically compare with that one. So here, heuristic analysis, it is only rule based. It's like a blind guy. It only follows the rules, nothing else. When we define some particular AXE and EXE files are coming in, just report to me. So a heuristic analysis only did when those files are coming, it automatically send the instruction to the database. And machine learning. There it can be used for normal methods and some advanced methods. In normal methods, those are the malicious files that automatically detects on the sandbox. A sandbox is a collection of whole malware signatures. So it automatically detects from it, and machine learning algorithm it detects what is a signatures available in the sandbox, or it is a new type of malware, or is there any existing malware types regarding this code, like that. In advanced method, it can be used for behavioral process. For example, if a malware enters your system, is do some malicious activity. So anti-malware in your system detects that change your properties or suddenly change your behavior. So it monitors it, and it will block the particular file. So advanced method in vulnerability exploitation prevention. So every software contains some vulnerability, which means some loopholes. So this malware what causes it will exploit the vulnerabilities in our system, which will cause the maximum damage to our system. So this method tries to block that process that exploits the vulnerability in the process which we are running program. So in whitelisting, so if the particular malware is there, it will validate that code and control, and after that only it will send request to the operating system to process it. So if anything undetectable or suspicious activity detected, it automatically whitelists that one, which we can't access at the particular time. And in the backend, the anti-malware software already will send some request to that software company regarding this one. In it is a micro virtualization is an Intel VT technology. It only executable in the Intel systems. It blocks directly the execution process of that particular software in an operating system. So in the image we can see that in the cyber exploit, attackers, it can be caused from person to the organization and target a particular whether it's a particular person, a particular company, or particular product, like Windows PowerPoint, and a particular technology. For example, 5G is the latest technology. What are the vulnerabilities in that 5G technology to exploit? And in the method, we can see so malware signatures and malware category. So already discussed before, and attack vector, which means how the malware can enter to the particular system, and operation after that enter malware into system, what the malware can do. So we did an survey on malware analysis, how the majorly malware analysis will happen. So as I said, discussed with signature based and same as static malware analysis. It just mainly focus on the information that is obtained from .exe or already have that particular information in the database. So it will collect the hash values from the strings, converts to byte, and compares that bytes to the previously existing bytes. It cannot detect the new type of malwares, but it can highly useful for already defined malwares. So in dynamic analysis, mainly focus on the behavior of the application. When we run the program, when we run the malicious program, it will use malware analysis. Anti-malware uses some type of graphs in that one. When the suspicious activity is detected, it automatically give the particular signals for that. And dynamic analysis takes much more time and much more complexity than the static malware analysis. And when it comes to the hybrid, it is a combo of static and dynamic malware analysis. It will just follow both the rules, but it can take more time to malware. What's the code running behind it? What type of malware, whether it is a virus or worm or Trojan. So it detects it wants some more computer resources and some real-time data. So we did some malware analysis regarding using the open source tools. So it is implemented in a virtualization isolator system. So when we implemented a particular malware in that, usually we use the Trojan, where when the Trojan is installed in a particular system, it automatically sends some data to the particular remote server. So in this example, we can see that data is going from one place to the malware host. So we use the three applications: DNS Chef and INetSim and Wireshark. And DNS is mainly used for the malware analysis, and it is one type of proxy detector. And INetSim is an well-defined banner for capturing suspicious activity. And Wireshark is a network traffic analyzer which automatically collects the data when the signals are coming from inbound to outbound network. So in comes to the conclusion, the estimated range of malware attack is completely increasing day by day, and the malware threats are not only caused with the individual, it will cause also the national security and user systems and industrial organizations also. So we did some research. There are around 350,000 malwares are created every day, and 7 billion malware attacks are occurring 2019 using 980 million malware signatures. So not only anti-malware, using the anti-malware, we can't protect all type of attacks from the malware. So we need some acknowledgement about cyber education. So with this, everyone can know what is malware, how it can have affect. What happened when the malware enters system? What are the terminologies is used? How the malware is sending data from particular user to the remote server. So in the last, there is no prevention for the malware attacks, and malware attacks is going every day and day by day, as we've seen before. Nearly 350,000 malwares are created every day. So we need to be more advanced, and we want to create a highly secure network for our mobile phones or laptops for accessing the data from our other side. Thank you.
Okay, thank you, Mr. Rohit. If anyone has any question, then they can ask. Okay, again, I am requesting to all the presenter that please conclude their presentation with maximum of 10 minutes, as we have to do 2 more session todays. So next I am calling Mr. Vikas Gupta for his presentation, and the title of his presentation is exploring the role of machine learning using artificial neural network in localization algorithm for wireless sensor networks.
Thank you, sir.
So now I'm handing over the mic to Mr. Vikas Gupta.
Thank you, sir. Sir, please see my screen is visible.
Yes, sir. Now it is visible.
Okay, thank you, sir. Thank you, Baba Farid Engineering College, for providing the opportunity to present the paper here. And I'm also very thankful to the keynote speaker, the Dr. Jayanta and Dr. Lalit Garg present here to have this kind of, experience. So I'm working on the area of actually the wireless sensor network, which is further, this was the part that we already covered in the IoT, and one step before this was the wireless sensor network, and now the people are basically facing this wireless sensor network in the form of IoT. So this is my outline of the work, the introduction to WSN, the localization algorithm, objective, ANN, related research, simulation setup, result discussion, conclusion, and the references. So in a very brief sense, as the time allotted by Mukesh sir is about 10 minutes, so let me cover that in this stipulated time. So wireless sensor network is a collection of the large number of sensor nodes. Those are closely deployed either inside the area of interest or very close to it to monitor an event or a process. So this is an example where this is an example for the hospital monitoring system where patient is there, which is wearing a jacket having different kinds of sensor, and that kind of information is actually floats to the network. With that network can be a multi-hop, the bus network, the ring network, any kind of network can be here. So on the basis of this, we are using some kind of protocol of the wireless communication, which is giving this information to the base station, and from the base station, it goes to the doctor, which is there at the remote location and observing the patient remotely. And this is the one of the, if we are working with the sensor, this is the basic composition of a single sensor having the power unit, the sensing system, the processing unit, the transmission unit. These are basic unit of these sensor. And one more thing is the position finding system and the mobilizer wherever we are, because mobility is always associated with a sensor. It can be movable or it can be fixed, and those are further connected to the base station. Then after this base station, they are internet and ultimately at the intended user. So here, this is the area which I have worked in the position finding system. As far as different issues, key issues are concerned in the wireless sensor network, these are the localization. Here, in case of localization, we are actually finding the position of the unknown nodes. Basically, whenever we are working with the wireless sensor network, we don't know where to, where we need to locate our sensors. There are some areas, there are some, for example, the battlefield, in case of some disaster management, we are randomly distributing our sensor nodes. And until unless we are not known that our sensor, the coordinates of our sensor nodes, the information received from those nodes will be of will not be of any use. So that's why we need to localize, we need to know the position of the nodes where we are spreading them. And another issue is the routing. This is related with the routing of the packets in the form of, the data in the form of packets. Usually we go for the flat and clustered approach, the energy management, because the wireless sensor networks, all these sensors are basically the energy constraints entities, and ultimately the network is energy constraints. And one of the unexplored area is the security. These are the basic, normally in the literature we are facing different key issues. Out of that I'm putting here. So I have chosen here the localization. So in the localization, we are dealing with the physical determination of the unknown coordinates of the sensor nodes. So one of the immediate answer in today's era about if we are finding the location of any person, we are talking about the GPS. And in case of GPS, until unless you are not having line of sight, we can't have the proper GPS. And one more thing, because I have already said, in case of our wireless sensor networks, the sensor nodes are the power constraints. Those are having very small power. So that's why we cannot have the kind of GPS power which which GPS is using. So that's why we need to devise some alternate solution. And that alternate solution in the wireless sensor network for the localization is basically classified in the two categories, the range based and the range free. In the range based, we are working with the time of arrival, time difference of arrival, angle of arrival, received signal strength indication. All these falls in the category of the range based, and these require some, some costly hardware to localize our, to know the location of our sensor nodes. But we are using, normally in the literature, we have different kinds of paper on the range free algorithm. Those are the 8-bit approximation point in triangulation test, MDS, that is multidimensional scaling, DB hopes, and Troid base. All these I'm working all on these algorithm. But in this paper, we have I have taken the, I mean, the readings or the observation from the DB Hope algorithm. So DB Hope algorithm is nothing but it is a classical distance exchange vector method in which we are finding the distance between the anchor nodes and the unknown nodes. Unknown nodes are basically the nodes. Those are we are distributing randomly, and anchor nodes are the nodes. Those are having some kind of GPS-like arrangement. Those, some of the nodes know their location, and on the basis of that, we are performing these kinds of operations. So we are finding the distance between unknown nodes and the anchor nodes, and on the basis of that, each node maintain a table, and that table contains the coordinates of the anchor nodes xi, yi, and hi. This is hi stands for the hope count, and ultimately on the basis of that, we are going to calculate the average hope size from this formula. And further, we are using the these distance equation, and this distance equation is actually taken in the form of triliteration. And this triliteration is a technique to find the location of the unknown nodes. Here A, B, C, these are the anchor nodes, the reference nodes, and this D node that you are seeing in the center, this is the unknown nodes. And on the basis of this, I want to have the location of the D node, and I'm using here some kinds of the matrix equation to find the location of these nodes actually. So on the basis of this, we are having the ax is equal to b, and we are finding the unknown coordinates x and y by using these formulas. And after finding the location of these nodes using this DB Hope algorithm, we are going to calculate the performance measure, the localization error actually. So localization error is actually nothing but is the difference between the estimated location and the actual location where we have placed the sensor nodes. So whenever I talk about the localization error, this is the performance measure. And here, one of the main performance factor all together, the localization technique used in the literature, this is the performance factor. This is the performance measure which we need to optimize. Actually, in the case of DB Hope, original DB Hope algorithm, there is a large localization error, and which is a cause of concern actually. And that's why we are implementing in the literature different kinds of, heuristic technique have been used. The PSO, the ABC, and different kinds of algorithm have been used, differential evolution. But in here, I'm working with the ANN, and I want to find the, effects of this ANN on this localization error. So for that, this is actually the objective. So for that, we are working with the ANN. ANN, this is, needless to say, this is the collection of the nodes, and a single node is basically, it is a single node that we are representing here is to impersonate the behavior of a biological neuron. You know, in our head, in the brain, we are having billions of the neurons, and this is the artificial view of that single neuron actually. And this single neurons, in terms of our sensor networks, or simply the network, this is called as the node. And these are the inputs. This W represent the weights, and this is our some kind of summer we are using here, and this is some bias value, and we are using the activation function and getting the output. And this bias is actually nothing but to shift your weighted output actually, that we are getting in the summer. Fine. Whatever I have found in case of ANN or the machine learning is, this is kind of mathematical adjustment. You are working on the things as per your desired output. For example, at the output, I want to have the desired output. I'm having different functions. I can have the linear, I can have the function here, the log sigmoid function here. I can have different function, and if I'm working with this again and again, getting the output, then feeding to the input, getting the output, feeding to the input, this process is called as actually the learning or the training. And this kind of, we are having the, if I broadly classify, this is supervised learning, the unsupervised learning, reinforcement learning. These kinds of learning are there. In case of supervised learning, you are having the some master to judge your performance. And in case of unsupervised learning, there is no any kind of feedback. In case of reinforcement, this is the basically the combination of these two. So these are having different application actually. Next is the related research. Although I have referred to different kinds of resources available in the literature, but most of the time the people like M. Golmi, the Kumar et al., the A. Payal, the Samantha et al., right from the 2013 to 2018, those all are working on this ANN based, and those are using different parameters to localize or to optimize the performance of this localization error actually. Most of the time they have achieved, like say Kumar et al. Achieved 0.70 meter, 2.922 meter, achieved by Samantha. All these were using different, I mean, the localization algorithm or the things, the parameter to simulate their model. But here we are using the distance between the anchor nodes and the unknown nodes as the input, and I'm taking the localization error, the performance measure, as the output. And on the basis of that, I have taken the desired output here, 0.01 meter, the localization error. And for that, we are using here the multi-layer perceptron model. We are having the input, the hidden layer, and the output, and in the output we are having the localization error, and we are actually obtaining these output very near to the 0.01 meter. Fine, this is a simulation parameter that we have conducted for the DV-HOPE algorithm, the network area, number of nodes, the anchor node, the communication range. And in the same way, we have taken the parameter, the readings that have taken from the ANN is basically, we are having the sample size at 82 readings are there, which says the distance between the anchor node and the unknown nodes gives, let's say, some kind of error. This is one of the reading, and these kinds of 82 readings I have taken, and on the ANN Simulink using MATLAB, it by default divides this 82 readings, 82 observation into a training, the validation, the testing. 52 have been used for the training, validation ke liye 12, and for 12 for the testing. And Levenberg-Margard backpropagation algorithm by default it is using, although there are other algorithm also, but because of some paper in the literature I have considered this Levenberg-Margard algorithm. The performance measure here is mean square error, the number of hidden nodes. Actually, the hidden layer was there inside this. I'm varying the number of nodes in the hidden layer. So we have changed it from 10 to 20, then 30. And activation function, we have used the sigmoid function for the hidden layer, and for the output, we are using the linear model. And weight updation, by default, it is there in the MATLAB from 0 to 1. So this is the kind of results. Actually, we are getting the number of neurons in the hidden layer of 31. I mean, 3 layer may, in case of ANN 10. If the nodes are 10, then 20, then 30. On the basis of that, we are getting the MSC, the gradient. I mean, the R for training, R stands for the correlation, for validation, the testing, and the overall correlation. These are the factors on the basis of I have performed the simulation or the kind of performance related to the ANN. So this is the window which is representing the progress of simulations. Here we are, you can see we are using Levenberg. Sir, I'll take only 2 minutes only, please. And this is the mean square error we are performing here. The performance parameters are performance, training state, error histogram, regression, and the function fit. So this is the error histogram, which shows the error between the target and the output. Target was actually 0.01 meter, and the outputs that we are getting at each and every instant. So this is normally varies from minus 0.38332 plus 0.3827. This is that overall variation. And this actually beans also show the MSC error in the form of training, the validation, and the test also. This is showing for all the parameter, and this is the error plot for the desired and the target. It is separately representing the difference between the targets and the output. This is the gradient, and the MU. This validation check actually shows the how fast your, I mean, how fast your simulation is getting completed. Because so sometimes I usually think that this is finishing at 7 epoch. The reason is, if this can also be a question of any participant, this is why it is working only of 2.7, because the number of, it depends upon the number of sample size. Because here the ANN or the deep learning or the machine learning, the sample size must be very large, and that's why this is collapsing at the 7 epoch only. So this is the correlation regression plot, which is actually showing there is some kind of relation between your output and the target. And normally it is said that if this relation is less than 0.05, this is not a very good fit. And if this is 0.05 or less than 1, then it is having some kind of relation. That's why this is our regression plot, which shows that there is some relation between the output and the target. And I will conclude here. We have studied the correlation between the localization error and the distance, the hidden layer. Here we find that as we increase the number of nodes in the hidden layer, the mean square error decreases. If we decrease from 10 to 20, this error reduces by 11.78%, and from 10 to 30, if you get that, it is 38.8%. So as far as the future work is concerned, we can consider different parameter for the simulation work. So this is the references that I have taken. Thanks a lot, sir. Thank you, Mukesh sir. If you are having any kind of query, I can take that. Thank you.
Thank you, sir. Thank you very much. Okay, if anyone has any query, then you can please ask from Mr. Vikas. Okay, sir. Thank you very much.
Okay.
Due to the shorter running of time, so I again request to all the remaining participants to please conclude their presentation within 7 to 8 minutes. And for the next paper presentation, now I am calling Mr. Haz Brahim for his presentation. And the title of his presentation is A New Image Encryption Based on 2D Compressive Sensing and Multi-Choice. So now I am handing over the mic to Mr. Brahim.
Thank you, sir. Thank you, sir.
Good morning, everyone.
Yes, sir.
I am a PhD student in University of Science and Technology of Oran Mohammed Boudiaf, Algeria. Today, I'm going to present a paper with title A New Image Encryption Algorithm Based on Truth, Decompressive Sensing, and Multi-Core. One of the standard signal processing, we say that the perfect recovery of the signal sampling frequency must be higher than twice maximum frequency of the signal. So, in the digital camera, after taking a picture, the first step is sampling the signal to obtain n samples. Then it must reduce the number of samples by using the compression to obtain only k elements, when k is much lower than n. After this step, the picture can be transmitted or stored. The problem is why we sample n times when we are going to eliminate the measure of these elements. Recently, a new technique is proposed called compressive sensing, which allows the signal to be sampled and compressed in one step. In the compressive sensing theory, the sampled rate is much lower than the shallow liquid rate. Compressive sensing based on the sparsity of the signal, which means that the measure of elements of the signal are equal to zero. Here, the measured element of the signal are equal to zero, while only 4 elements are different to zero. In most of cases, signal can be sparse in different domains, such as the discrete cosine transform, discrete Fourier transform, discrete wavelength transform. Here, signal X is not sparse, but it has a sparse representation alpha in a domain C. The theorem of compressive sensing is a sampling multiple between the sparse signal and the measurement matrix. If the signal is not sparse, it can be replaced by its representation in the specific domain C. Here, X is the original signal, C is the measurement matrix, Y is the measurement vector. To guarantee that the original signal X can be recovered from the measurement vector Y, the measurement matrix V must satisfy the restricted symmetry property condition. By satisfying this condition, we can guarantee that only one X can be recovered from the measurement vector Y. There are many recovered algorithms of compressive sensing such as minimization L0, minimization L1, minimization L2. Solving the first equation requires an exhaustive search of sparse solution and it is very complex to implement. Studies show that the second algorithm is the best algorithm of recovered signal in compressive sensing compared to the other two algorithms. This is our proposed algorithm. Firstly, the plane image is transformed to sparse compression matrix with the same size using discrete wavelet transform. Secondly, the permutation is applied to the sparse matrix. All rows are shifted to the right by a specific value R. Then all columns are shifted to the left by another value C. Thirdly, generate two measurement matrix P1 using four one-dimensional counting systems. Each two counting systems are generating one measurement matrix. After generating the measurement matrix P1, P2, the 2D compressive sensing is applied between measurement matrix P1, P2, and shifted matrix, which means applied compressive sensing twice to obtain square matrix of the zipper image. For decryption process, we use the smooth L0 norm algorithm to inverse the compressive sensing. Then the inverse permutation is applied. First, inverse shift columns, then inverse shift row. Finally, inverse discrete wavelet transform to obtain the decrypted image. The chaotic systems used in the proposed algorithm to generate the measurement matrix are: first, logistic map; second, sign map; third, logistic 10 system; finally, 10 sign system. To generate the measurement matrix, the chaotic systems are generated 1000 plus m multiplied by m multiplied by times, where d is the sampling interval, m is equal to cf multiplied by n, where n is the size of image and cr is the completion ratio. By abandoning the first 1000 elements of the sequence of the chaotic system and sampling the sequence by the sampling interval d, new sequence is obtained. By combining each obtained sequences, two sequences are obtained, P1 and P2. P1 using the first and the last sequences, P2 using the second and the third sequences. The sequences P1 and P2 are rearranged in a columns manner to obtain two measurement matrices, P1 and P2, where square root 2 divided by n is used for normalization. For 2D compressive sensing, the theorem is multiplying the first measurement matrix by the sparse signal, then multiplied by the second measurement matrix transposition. For experimental results, we take a Lena image and a Brown image with size 256 multiplied by 256 pixels. In our proposed algorithm, we take the compression ratio equal to 0.15, which means the size of the reflected image is 128 multiplied by 128 pixels. We can see that the decrypted image has the measured information of the original image, and the eye of a human cannot see the difference between the decrypted image and the original image. One of the important tests in compression is the peak signal to noise ratio, PSNR, which measures the quality of the decrypted image after the image processing. The higher the PSNR means that the decrypted image has less difference from the plain image. In addition, another important test called structural similarity index measurement SSEM measures the similarity between the plain image and the decrypted image. The value of SSEM is between 0 and 1. The more similar the decrypted image is to the plain image, the closer the SSEM is to one. From the table, we can see that the average BSNR value of our proposed algorithm is about 32 dB, which indicates that the decrypted image has less difference from the plain image with only compression ratio equal to 0.5. In addition, the SSEM values are close to 1, which means that the decrypted image is very similar to the plain image. The histogram of the plain image, Lina and Brown, and their corresponding cipher image. The histograms of the cipher image are very similar, and they are different from those from plain image, and the number of each pixel value of the encrypted image are almost equal, which means that the cipher image cannot give any statistical information about the plain image to analyzing the histograms of the cipher image. Another important test called the correlation between adjacent pixels. By randomly picking up 10,000 pairs of adjacent pixels from plain image Lina and its respective cipher image in the horizontal, vertical, diagonal directions, we can see that the pixels of the cipher image are distributed in the whole coordinate space, and there are no correlation between pixels, which means that the proposed algorithm has good confusion performance. Any image encryption algorithm, the case space should be larger than 2 power 100 to resist brute force attack. In our proposed algorithm, the case space consists of 4 initial values of the chaotic system, shift rows value, and shift columns value. Assuming that the computation precision of the computer is 10 power minus 15, and if the 2 shifted values take 8 bits of each value, the total case space is larger than 2 power 260, and it's larger than 2 power 100, which means that the case space of our proposed algorithm can resist brute force attack. Finally, a conclusion. In this paper, a new image encryption algorithm based on 2D compressive sensing and multi-cores is proposed. 4 chaotic systems are used to generate 2 measurement matrices. 2D compressive sensing is used to compress and encrypt the plain image. Simulation results and performance analysis show that our proposed algorithm has a high probability of resisting statistical attack. Thank you for listening.
Thank you, sir. Thank you very much. So for the next paper presentation, we are inviting Mr. Pulkit Jain. And the title of his paper is Design of an Intelligent System Based on Machine Learning and IoT for Smart Refrigerator.
Okay, sir. Good afternoon to all present. Is my voice audible, sir?
Yes, sir. Your voice is audible.
Okay. The topic of the paper is Design an Intelligent System Based on Machine Learning and IoT for Smart Refrigerator. The main idea behind this paper is to avoid food wastage by making an ordinary refrigerator smart enough at a cost-effective manner instead of designing a brand new refrigerator, which is a very costly affair. So here in this paper, it is not about designing a smart refrigerator. It is designing a module which can make any ordinary refrigerator a smart refrigerator. So that's the difference I want to clear first of all. So this paper deals with the design of the intelligent module using the concept of TensorFlow, which is a machine learning library, and IoT concepts, which can be fitted to any refrigerator. Only one-time hardware installation will be required, which will add enough features to make it smart and modular enough. So in this, so Samsung Family Hub, this is the Samsung, LG, they already have smart refrigerators, but they are very costly, near about 2.75 lakhs or 3 lakhs. So in the literature also, I found that the researchers are trying to design some intelligent modules to make a refrigerator smart rather than designing a whole full-fledged smart refrigerator, which is a very costly affair. So for literature review, I have considered Web of Science, and these are my results. So total, these papers were considered, but I have applied certain inclusion and exclusion criteria, out of which 30 articles were retrieved first of all. The criteria is mentioned over here in the screen. Like 1086 articles were excluded after title and abstract screening because they were based mainly on IoT challenges, IoT utility and security aspects, medical and vehicle refrigerators, simulation studies on user acceptance. But my aim is to look for only those papers which have talked about the designing of an intelligent module for the refrigerator. Then this 30 articles, again, this criteria was applied as mentioned over here, where the snapshots of proposed system were missing. Real testing on the fridge was not carried out. So those were excluded and only 14 articles were finally considered for literature review. This is the list of the first 8 articles, and then the remaining 6 articles, total 14 articles were considered for review. And this is the parametric comparison being done of all these 14 papers based on number 1, which is the food scanning technique, whether they have gone for RFID tags, barcode scanning, fuzzy approach, artificial intelligence based, simple image sensing. Then I have listed the control and sensing module as well. Then cloud platform, whether they are sharing the data over the cloud platform or not for the remote access. Food expiry check, whether it is being carried out, yes or no. Notification, how it is given to the user, and the novelty in the paper. So these are the features. I would just jump to the review analysis of this. So analysis is that although extensive research has been performed, but even very smart, costly fridges are available, but yet limited research has been reported where the designing of a modular refrigerator has been talked about. So that is the concept which has been referred to in this paper. Also this point, not much articles which can be found about the combination of IoT and machine learning in the design. And last point is very important, which is the novelty of my paper. No article can be found which talks about placing the weight measurement system outside the fridge, because it will help in avoiding the mess of wiring inside the fridge. That system has been implemented. This is the hardware setup. As you can see, this will be the fridge. A weight sensing tray is there. This is the 3D CAD drawings shown of the weight sensing tray, which will consist of a load cell and the ADC module for weight sensing of the item. Camera at the top of this tray, focusing downwards on the items to be scanned. A display screen for displaying the content inside and other information, and Google Cloud for transferring the data for the remote access. Now I'll come to the block diagram just to tell you about the procedure, then I will come to the results. So here, initially, what will happen? The user, upon if he wants to enter some item into the fridge or wants to remove some item from the fridge, a weight sensing tray I have added. This will be a foldable tray on the one side of the refrigerator, and the intelligent module, all the processing unit will be at the top. So nothing is inside, everything is outside. This this weight sensing tray will consist of a load cell. So as soon as the item is inserted, the weight will be noted, camera will take the image and it will identify. Then after a certain idle period of time, if no further input is being there from the user, the camera will process the data, which item is there, whether it is apple or any vegetable like tomatoes or any capsicum and any other item. That will be identified, its weight was noted using the load cell, and that entire data will be processed via my main processing part, that is Raspberry Pi, which will send the data over to the cloud as well. And I have designed an Android application for the remote access that I'll show you the screenshots. And finally, a display screen will be there, which will show the database of what actually the content are there in the fridge, in what quantity, in what weight, and I can also extract the items which are scarce in number. And moreover, if I have the remote access, if I'm there standing in a mall, in a market to purchase my fruits and vegetables for my fridge or for my household, then I can directly access all the database of my fridge at a remote location using the Android application. So testing has been carried out of load cell. Initially was done using Arduino Uno, then followed by design and testing of weight measurement module was done, followed by barcode scanning, because some items they also have barcodes. So barcode scanning algorithm was tested using the Python programming. Then the data set for training of my machine learning algorithm. So I searched for various data sets, Fruits 360, FIDS 360, and other data sets were initially selected. But finally, this NVIDIA Jetson Nano dataset was being finally selected because it gave me good quality results, means no constraint was there on the size of the images, high accuracy was achieved, and moreover, the time taken for training the network was also very, very minimal. Rather than this Fruit 360 dataset, which required so much large amount of time to train my dataset. Lastly is the results. So this is the setup being done. This is not installed in the fridge, but I have made it externally just. So here an orange has been identified with 97% accuracy. Then I have taken various scenarios, dim light, bright light, multiple items, items held in the hand, being blocked by the hand. These are the results shown. So network performed well in single fruit scenario with accuracy of greater than 85%, in multiple fruits as well. But under different lighting conditions in bright light and dim light, it didn't perform that much well. So that I'm working upon. Fruits and vegetables covered with human hands, no problem at all. Data set is working fine. But held in human hand. Okay. So one is obstruction, one is held in the human hand. So it is working, but accuracy is not that good. Okay. It is coming near about 60 to 65%. But the good part is the recognition time is very small. It is near about 10 to 15 seconds in this system configuration, CPU i5 fifth generation, and 30 to 45 seconds in Raspberry Pi. These are the snapshots of the Android app developed. You can see the date and time. Available fruits will be shown here in the form of database, time, weight of fruits, and everything else. So coming to the conclusion. So from the literature review, it can be found out that literature research has been done towards the designing, but only a limited amount of research is there in designing a smart module. So this paper deals with the detailed design. Weight measurement system, image sensing and processing unit has been kept outside to avoid the mess of wiring inside the fridge, which is the common issue as revealed from the literature review. The major outcomes of this system will be, because I have only discussed about the design, the implementation part is going on. So the major outcomes will be optimum cost. Any ordinary refrigerator will be converted into smart refrigerator. Fruit and vegetable scanning will be done, identification, trained by machine learning algorithm, food expiry check, and remote access. So future scope is the implementation part and trying to improve the accuracy of this. So I thank you everyone for your patient listening. If you have any queries, you can ask now.
Thank you, sir.
Okay, sir. Thank you.
So if anyone has any query, then they can ask from Mr. Pulkit Jain.
Sir, I would like to know that what is the future scope of this project that you are doing, and are you collaborating with any like patent-based application so that we can improve this application to the next level?
Yes, sir, for sure. I am looking for patenting this type of product. But first of all, its implementation.
Because if you really want to go for the next step of this, I would like to recommend, because actually I'm also working on this type of technologies and I have already patented 8 patents with Australia. So your project seems very good, but the main thing is I need to understand, I need to work more with you closely in terms to understand the working prototype so that we can see its critical application. As I was the session chair yesterday, again, I am repeating the same thing to all the participants that when you're working on IoT especially, the main thing is to go for the design of a critical application with a ready-made prototype so that you can analyze what is the data, and after that you can do some analysis on the data. So if you can do something on that, then I will be supporting you for the patent. This can be patented. Hello. Hello.
Yes, sir. Your voice is audible.
Okay. Actually, the participant didn't responded
Yeah.
me. That's why.
Mr. Pulkijan, are you able to listen the voice of Dr. Anand Nair?
No problem. No problem. Go ahead, sir.
Okay, sir. At the last, I would like to request Professor Dr. Anand Nair to conclude this session.
Okay. Thank you so much, Mr. Mukesh Kumar, for inviting me today also for the session co-chairing. And I have observed some of the papers that some papers are really nice. And the main stress is towards that we can take this, the ideas towards a real-time implementation. And we must be all doing towards more motivation. But the last paper that I would like to comment that it was really a remarkable paper and the work that can be extended to the real-time application. Thank you.
Thank you, sir. In the last, I would like to request Dr. Shalu Gupta to thanks all our guests and the participants to join this session. Ma'am Shalu Gupta.
Good afternoon to all. Thank you, Professor Lalit Garg and Professor Yumnam Janta Singh and Dr. Anand Nair. First of all, on behalf of BFJI, I would like to express my sincere appreciation and gratitude to Professor Yumnam Janta Singh, who gives wonderful talk on e-waste management, and Professor Lalit Garg, which gives talk on artificial intelligence, which helps in health due to COVID. And I also thankful to Dr. Anand Nair, who chaired this session. The theme of this session is Advances in Artificial Intelligence and its Applications. I would like to express my thanks to presenters Madhav Gupta, Rohit, Vikas Gupta, Pulkejan, and Brahim. The session is very interesting and appreciated by all the attendees. It's very useful information that is sure to motivate many aspirants. Sharing this experience with same of many leading researchers is a great opportunity for all of us. Thank you to all. We look forward for the other sessions also. Thanks to everyone. Thank you.